Now that you have a better understanding of scaling, let's turn our attention to the focus of today's program, which is scaling the solar system. Dr. Sten Odenwald, an astronomer and scientist at NASA Goddard Space Flight Center, has a scoop.
Thanks, Jennifer. When we talk about the distances between points of interest, we instinctively use units that make sense to us and that are convenient. For example,
what unit of measure would you use to describe the distance from Washington, D.C. to Los Angeles, California? Would you use miles, inches, kilometers, or meters? What about your height? Would you measure it in inches or feet? And how about the width of your classroom? Do you use kilometers, meters, or feet? You can choose any unit of measure you wish, as long as it's convenient for everyone to understand.
When describing distances at the scale of the solar system, even units like miles and kilometers lead to numbers that are in the millions or the billions, and that makes it very hard to understand them.
For example, the distance between the Earth and the Sun is about 149 million kilometers. Between the Sun and Pluto, the distance is about 5.9 billion kilometers. But suppose we wanted to compare these two numbers. It's not easy to see that Pluto is about 40 times as far from the Sun as Earth is.
It would make sense to use a smaller scale in order to get a better idea of the distances between the planets. To come up with that scale, we have to define a baseline.
The baseline that astronomers use is the distance between the Earth and the Sun. This distance is known as the astronomical unit. The astronomical unit, or AU, represents the distance between the Earth and the Sun, which is about 93 million miles. The astronomical unit is the baseline that astronomers use to determine the distances to the planets in our solar system and to the stars beyond.
So let's have a look at the scale of the solar system, where 1 astronomical unit equals 93 million miles. Based on the astronomical unit, it's easy to compare the distances between all the other objects in the solar system. The accompanying chart shows the distances to the planets from the Sun in terms of astronomical units.
Let's look at Mars. We can quickly see that Mars is 1.5 times further away from the Sun than Earth is. So how far is Mars from the Sun in miles? Remember the process Jennifer demonstrated earlier in the program to solve problems involving scaling? We can solve the Mars distance problem using a proportion. The first ratio is the scale, and the second ratio is the distance of Mars to the Sun. And miles represents the distance from Mars to the Sun. After setting these ratios equal to each other, let's find the cross products. The equation becomes 1 times n equals 93 million times 1.52. Multiplying, we get the distance from Mars to the Sun to be approximately 141 million miles.
Using the astronomical unit instead of the mile or the kilometer makes it easier to compare the distances between the planets and the Sun. For example, it's easier to remember that Mars is 1.5 times further away from the Sun than the Earth than it is to remember that it's 48 million miles farther away from the Sun than the Earth. If you recall from earlier in the program, the Voyager spacecraft is 8 billion miles or 13 billion kilometers from the Earth.
It's at the far edge of our solar system, ready to head out into interstellar space. Based on what you've learned about scaling and the astronomical unit, can you estimate the distance of Voyager 1 from the Earth in astronomical units?
Working with a partner, take a few minutes and see if you can solve this problem.
Voyager 1 is over 8 billion miles away from Earth. Estimate how far, in astronomical units, Voyager 1 is from the Earth. Remember, the scale is 1 astronomical unit equals 93 million miles. Teachers, you may now pause the program so students can answer the problem.
Okay, so what did you come up with? If you said that Voyager was 86 astronomical units away from the Earth, you're correct. Do you have a sense for how far that is? The planet Pluto is 40 astronomical units away from the Earth. So that means Voyager is twice as far away from the Earth as the planet Pluto.
Suppose that Voyager 1 were stationary and you were able to ride in a car traveling at 55 miles per hour to get to it. The trip would take you over 16,000 years just to reach the satellite. That would be quite a lengthy and expensive vacation.
Jennifer, I think the students are ready for that hands-on activity now. Could you send them back to me when you're finished? I have a real tough question for them to answer.